Hello, my name is Ian Cody. My presentation is on Death Valley. I have divided the presentation into three parts. In part 1, I will talk about the geologic history. In part 2, I will talk about plate tectonics. And in part 3, I will talk about how the climate and weather affects Death Valley. Part 1, Geologic History. To start this section, it is important to know where Death Valley is. Death Valley lies between two states. It is located in the states of California and Nevada in the United States. It is mainly in Inyo County in southeastern California. It is the lowest elevated location in North America. Badwater Basin in Death Valley is 282 feet below sea level. The weather here is known for being the hottest in the world and extremely dry. The highest recorded temperature is 134 degrees Fahrenheit. Death Valley is a large geologic site. The length is approximately 140 miles long and the width is from 5 to 15 miles. To the west is Panamint Range and to the east of it is the Armagosa Ranges, Black, Funeral, and Grapevine Mountains. It is located between the Great Basin and the Mojave Desert. A common misconception is that Death Valley is a barren wasteland. That is a false assumption. Death Valley is not completely filled with the typical desert land. In fact, about less than 1% of the desert consists of dunes. There are cold parts of Death Valley. There are mountains that are covered in snow. There are steep canyons. The soil is sufficient for maintaining plant life. There are also meadows of wild flowers. This landmark is important because it portrays 2.5 billion years worth of geologic history. Death Valley is classified as a closed basin. A closed basin is a body of water that is draining, but the water does not flow out into the ocean. Native Americans have lived in Death Valley as long as 9,000 years ago. They were here in 7000 BC, long before the European settlers arrived. European explorers discovered this location in 1849. They were trapped in the valley as they were exploring for an alternate route to the goldfields in California. The explorers described their 2-month stay as consisting of hunger and thirst and an awful silence. This led to Death Valley earning its name. Only one person died in the group of explorers. This is the reason behind the name Death Valley. Originally, the purpose to travel to Death Valley was to mine gold and silver during the gold rush. However, these precious ores were uncommon and difficult to find. It was almost pointless to search for them. Borax, also known as white gold, was the main profitable ore. Today, tourists visit here because of its various geologic features. Although Death Valley has the name Death in it, it is actually a home to a wide variety of plants and animals. A few examples of plant life are saltgrass, desert wildflowers, and juniper. A few examples of animals living here are rabbits, ground squirrels, desert wood rats, coyotes, kit foxes, and bobcats. This is also an environment that is a home to small fish. They are located in the bodies of water. Part 2, Plate Tectonics of Death Valley. The oldest rocks in Death Valley are about 1.8 billion years old. This dates all the way back to the Precambrian era. These rocks were volcanic and sedimentary before. They were transformed into metamorphic rocks, such as schists and gneisses, due to intense heat and pressure underground. First, these rocks were involved in a volcanic mountain range. There were layers of sand and mud on them. They were lifted up and exposed. This created the Black Mountains and Panamint Range. The sedimentary rocks that remain on top of the metamorphic rocks are the Pahrump series. They are approximately 1.3 billion years old. They have been raised and were eroding. This led to sediments entering into the local ocean. Death Valley used to be a warm, shallow sea around 550 million years ago. Limestone and dolomite layers were formed. This can be seen in the mountains. Layers of quartzite were formed when mud and sand were deposited. This created mountains and tectonic activity in the north of Death Valley. About 225 to 65 million years ago, Death Valley went through a major shift. It used to be a stable margin. Then, it became active. Volcanic activity, the creation of mountains, and tectonic plate movement took place. This is a result of the continent of North America colliding with the Pacific Ocean plate. A deep trench was created when the oceanic plate subducted underneath the continental plate. When parts of the ocean plate sank and melted, volcanic eruptions occurred. During the Paleozoic era, approximately 542 to 251 million years ago, the Funeral and Panamint Mountains were covered by a shallow ocean. The limestone and sandstone provided this information. Magma chambers under volcanoes formed due to subduction in the Jurassic and Cretaceous eras. Plutons, a type of igneous rock, formed when it cooled and solidified underground. A small portion of Death Valley consists of these plutons. The tectonic activity calmed down in the Jurassic and Cretaceous eras. The rocks were brought up and eroded. Sediments were brought down from the higher levels to the lower levels. In the Miocene era, activity took place again. Volcanic activity and faulting continued. Instead of colliding and sinking, stretching and spreading happened. This began the tectonic activity that formed Death Valley to how we see it currently. In the Cenozoic era, Death Valley began to shape and form due to volcanic activity and tectonic plate activity. During the late Miocene to the Pliocene, compression and folding took place in the Avawatz Mountains. This created a reverse fault system. The tectonic plate activity created the complex structure of Death Valley. In the west, there are strike-slip faults on both sides of Death Valley. In the central part, there is a pulled-apart basin. As the sides spread apart, the valley is pulled apart and sinks down. Oblique slip faults are when strike-slip and normal faulting occur. This happens when the faults traveled sideways and vertically. The Garlock Fault to the south of Death Valley is a left lateral strike-slip fault. This is stretching the valley. It is pushing the Panamint Range to the west. This results in Death Valley sinking along the Furnace Creek fault system. During the Miocene era, about 23 to 5.3 million years ago, the Earth's crust, where Death Valley is located, contained pressure. As the pressure decreased, the crust began to disperse, causing valleys and mountains to form. This is known as the Basin and Range Province. In the Pleistocene era, approximately 2 million years ago, Death Valley's shape has been established to what we see today. Death Valley differs than other valleys. Valleys usually form due to erosion. However, Death Valley was formed because of tectonic activity. Death Valley has sediments from the higher levels sinking to the lower levels, as mentioned before. To keep Death Valley below sea level, it is sinking faster than the sediment is collecting. It consists of a rugged topography. In it, there are also sand dunes, craters, and canyons. This shows how this geologic landmark has an intricate and unique history. The surface consists of 1.7 billion years old metamorphosed Proterozoic basement rock. However, there are rocks that are about 2.5 billion years old as well. This caused scientists to believe that Death Valley was a cratonic microplate called Mojave. It helped to build Laurentia, which is another name for the North American continent. Mojave formed in North America. The rocks, landforms, and structures provide plenty of clues to how this location was like in the past. The oldest rocks in Death Valley formed at least 1.7 billion years ago. However, the rocks alone have been incredibly altered, and figuring out its history is close to impossible. The most recent rocks, which have been formed about 500 million years ago, give more precise information to how it was like in the past. According to geologists, there used to be a sea within Death Valley. It slowly disappeared as the land rose and the water level sunk. The land rose due to compressional forces in the tectonic plates. The crust folded, warped, and fractured due to compression. Volcanoes play a role too. Volcanic activity contributed to the formation of Death Valley during the Tertiary period, about 65.5 to 2 million years ago. The crust was weak due to the faults moving and the creation of mountains. Magma rose to the surface and volcanoes erupted. The volcanoes appeared in northeast Nevada first. This caused layers of ash and cinders to form. As time progressed, the volcanic activity traveled westward. Eventually, a chain of volcanoes formed. This is from Furnace Creek to Shoshone. The magma caused the old rocks in the Black Mountains to get buried, adding another layer of rock. Another factor to consider is water. Water plays an important role in the formation of Death Valley as well. It relocates rocks, gravel, sand, and silt. The rocks travel down the hills and settles on the valley floor. At least 11,000 feet of sediment and salts are beneath bad water. At the Ubeheb crater, there is evidence of recent volcanic activity. These craters were formed about 2,100 years ago. The magma reacted with the groundwater to form rocks. This provides evidence that Death Valley is still changing and evolving. Erosion cuts through the rock formations. The basin is subsiding, and the mountains are increasing in height. Due to the continuous changes in Death Valley, it is literally impossible to absolutely know the future for this landmark. Death Valley is experiencing extension due to subduction, compression, volcanism, and plutonism. Part 3. The effects of weather and climate on Death Valley. Death Valley had a large system of lakes during the Ice Age. About 10,000 years ago, the lakes disappeared due to the increasing temperature. The water began to evaporate. Rainfall decreased and became rare. As more water evaporated, fields of salt remained on the surface. There is about 200 square miles of lake bed. There is a layer of salt that is as thick as 3 to 5 feet. The precipitates that remained are sulfates, chlorides, and mainly sodium chloride. In Racetrack Playa, located in Death Valley, a clay surface is created due to wind and precipitation. Summary. Overall, Death Valley has a complex and rich history. It is the hottest and driest location in North America. It is actually the hottest location on Earth. There used to be a system of lakes here. Eventually, the water evaporated due to increasing temperatures and less rainfall. Bodies of salt were left behind. Volcanic activity chains contributed to more rocks being formed. Erosion continues to cut away at the rocks. The rocks are at least 1 billion years old. However, when studied, it is obvious that the rocks cannot create a clear picture of how times were like in the past. They have been severely altered in this environment. Death Valley is continuing to get altered, but the future for this geologic landmark is unknown and impossible to predict. Here are the resources that I used to create this project. Thank you.